you. Yes, hi everyone. My name is Christine, and I'm a PhD student at the National Institute for Occupational Health in Norway, also known as STAMI. I'm here to talk about my PhD thesis, which are determination of proteins in air, if it is a new specific marker for airborne exposure in the food industry. Just a quick look at the outline. I don't have that much time, so I'm just going to talk about the relevance and the background why we are looking into the food industry. And I'm also going to present some results and the further work that we are planning to do. So in Norway, there is a total of 2.8 million employees, and 48,000 of these belongs to the food industry. This might not sound like a lot of people, but this actually accounts for 20% of all industrial workers in Norway. We already know that these workers are suffering from high levels of respiratory illnesses, and the most common ones that we are seeing is rhinitis and asthma. One of the major problems with the food industry is that it is quite diverse, so the potential harmful agents that a worker might be exposed to are really, really broad. And the occupational exposure limits that they use today are not really specific. They don't actually consider the specific components that are actually causing the illness in workers. For example, we are using flour dust as occupational exposure limits in the food industry, but the food industry is much more than just flour dust, which means that it will not actually be a good idea to use flour dust as an occupational exposure limit for workers that are producing coffee, for instance. And we also know that the exposure limits for flour dust, which are 3 milligrams per cubic in Norway, it's not actually protecting the workers sufficiently. So we have decided to focus on workers that are handling dry powders. And we have tried to cover as much of the diversity that the industry actually consists of. That brings us to the aim. Since the occupational exposure limits are not really specific, and we already know that it's not protecting the workers, we want to see if determination of airborne proteins will be a more specific and suitable marker for the occupational exposure in this industry. We also, not investigate, but we also hope that the knowledge that we're going to gain from this project will contribute to replace the current unspecific occupational limits for flour dust that the whole industry are relating to. The way we are collecting our samples are by personal air sampling equipments, but also stationary equipments. We use stationary equipments in order to get some knowledge about the background exposure that are in the different factories. And the reason why we also chose inhalable samplers for the personal participants is because we know that rhinitis and asthma are mainly caused by inhalation through the nose and mouth that will affect your lungs in the end. So far, we have collected 649 personal samples and 129 stationary samples that we are going to determine the total protein concentration of, but also something that's called the total inflammatory potential. I will come back to that. And we have had 204 participants in the project. So the reason why I'm showing you the concentrations or the total load of dust that we are collecting with each sample, each sampler that we are using, is that we can still see that approximately 30% of all our samples in the total industry are above the occupational exposure limits. And we can also see that the choice of sampler doesn't really affect that much. And as I should have mentioned, each participant are carrying a GSP sampler in parallel. That's in order to see if there are any differences in which side that you are attaching the equipment on based on the participant's handedness. Because if you are left-handed or right-handed, you might be working in different ways. So far, we have found that it doesn't actually matter. There are no significant effects on which side of the chest you will mount your equipment on, based on the handedness of the participant. As further work, of course, we want to determine the total protein concentration. We will use a method that are cheap and still reproducible and reliable, but one of the major challenges has been to have a good extraction method that will cover the broadness of the materials. If you are extracting cocoa powder versus flour dust, the extraction will be different because of the matrices that are caused when you are putting dry powders in liquid. In addition, we want to determine something that's called the total inflammatory potential. We use cells that are similar to your own immune cells. And this method will give us some indication about the dust that we are collecting and if it's potentially harmful for the workers that are exposed to it. And we hope that the correlation between proteins in air and the potential inflammatory in the inflammatory potential of the dust will correlate better than it does with the total mass that we are using today. And the reasons, of course, I should have mentioned that the project are, of course, focusing on determined proteins, because we know that allergens are proteins, and we know that allergens are causing disease in workers in this industry. And since there are not available equipments that can determine all allergens in a matter that are low cost and not that time consuming, we thought that it would be a better idea to see if the total proteins will give us some more indication about the exposure levels that the workers are exposed to. And if we have time, because it's quite time consuming because of the total data load I have collected, we will try to determine specific allergens which are not just in bakeries, because we know that the literature has mapped the bakeries really, really well, and the seafood industry are also getting more attention. But as some of you guys had a presentation about, the cheese factories or meat production, these are industries or sectors in the industry that actually are not getting that much focus. And that's what we are trying to do, to involve workers that are handling dry powders, but in the broadness of the production in the industry. So to sum up, the project will hopefully gain more knowledge about the exposure levels and it will also provide exposure assessments for the companies that are participating. Since we have included companies that we believe represent the broadness of the industry, we think that this project will give us actually knowledge about the whole industry with regard to workers that handling dry powders. And we have also already been able to give some advice on exposure reductions where it's necessary, because we know that bakeries are suffering from respiratory illnesses, as I mentioned, but the workers in other industries, or not other industries, but in other sectors in this industry are also suffering from respiratory illnesses. So we have tried to give some advice on exposure reduction based on mass, of course, since we haven't been able to determine the total protein yet. And we hope that with gaining more knowledge about the exposure with regard to protein concentrations and the total inflammatory, if this corresponds well, we hope that this more specific approach will contribute to replace the current unspecific occupational exposure limits that the industries are using today. Thank you.